of this topic, time, speed, distance. We started with the basic principle of speed, distance, and time. We discussed speed is equal to distance over time, and then we also discussed a problem on average speed, and we learned that average speed is always equal to the total distance by total time, right? I also discouraged you from learning a method, a formula of average speed, which is defined as 2 times of ab upon a plus b, because that's specifically for the conditions where the distance traveled in both the cases are same. So if the distance traveled change, then this method does not apply. Therefore, I encourage that every student should stick to the basic, which is the total distance over total time gives us the average speed. Although in case of average speed also there are two scenarios. For example, uh, if you discuss a question that we discussed in the previous class only, then the question was that there is a person who goes from his home to his office at a speed of 20 and comes back at a speed of 40 kilometers per hour. So what is the average speed during the journey? So here, if we plot the graph of it, then we should understand that the speed is always maintained for several times. It is 20 and then suddenly it jumps to 40, and then while coming back, the speed is 40. Whereas there can be another scenario as well, where the speed is constantly changing, such as this. This is the case of constant acceleration. Similar may be the case of constant deceleration if the speed is constantly decreasing like this. In such cases, the average speed may be calculated as the first speed, that means initial speed, plus the last speed divided by 2. However, such questions are usually not available for the GMAT. Therefore, you can always avoid this kind of a concept. Now here in this session, I'll quickly discuss several problems around the similar things. So let me clear this up and then take you to another concept. Okay, so here the question that I wanted to discuss where the formula is not applicable, that is somewhat like this. A child goes from his home to his school, and while going from home to school, he cycles at a speed of 10 kilometers per hour. On reaching school, he realizes that that's a holiday. So he immediately starts coming back, and he plans to party at some McDonald's restaurant, which is exactly on the midway. Exactly the midway. But he comes back, he cycles at a speed of 20 kilometers per hour. He comes with the friends. Now the question is, what is the average speed during this entire journey? So we have already understood that average speed is calculated by the total distance divided by the total time. Now here once again we will use the same principle. While going forward from home to school, let's assume that the distance traveled was d, but while coming back the distance traveled will not be d, it would rather be d by 2, because I mentioned in the question that the MACD is exactly on the midway. While going forward, the total time taken can be calculated by the distance over the speed. While coming back to MACD from school, the total time taken can be calculated by d by 2 divided by 40. Oh, here the speeds are 10 and 20. Now we can once again simplify them. 3d by 2 here, and the LCM is 20. So we get 2d plus d by 2 is equal to 3d multiplied by 10 divided by 5d by 2. D gets cancelled out, and then we get 12 kilometers per hour. That's how we calculate the average speed in this scenario. Now if you use the property 2ab over a plus b, that won't apply, and that is why I discussed that this method is far more better, because it has the basic very clear that the average speed is dependent on the total distance and the total time you have to calculate it to answer the question. Now I'm going to take you to another question that's also a pretty beautiful question, and with the help of two more additional questions, I think we'll be able to summarize the entire topic time, speed, and distance in context of the GMAT related questions. So let me quickly clear this board up. Now another question. Please listen to the question carefully. The question is, a man walks from home to office every day. He starts same time every day and he reaches office on time, and he reaches office every day at sharp 10 a.m. Right? Now I'm going to bring in some change. The change is one day, due to traffic, his speed reduces by 25% and he reaches office at 10:30. Now the question is, at what time does he start his journey from home to office? That's a question. You can just take as much time as you want. I'm going to quickly answer this question based on the understanding that what needs to be done to answer this question. See, the scenario is like this. There is some place, his home and his office. The man walks from home to office. Let's say he maintains his usual speed s. He takes his normal time t and then reaches office sharp at 10 a.m. One day his speed reduces by 25%. So speed minus 25% of speed becomes 3/4 of speed. So next time he is walking at 3/4 of his usual speed, and now he reaches office at 10:30 a.m. So at what time does he start? It's a question in which it's very important for us to quickly decide how to connect these two scenarios. This is scenario number one, this is scenario number two. Scenario number one is the scenario with the usual speed, and scenario number two is the scenario with some different speed. So here we only have three things to think about: the speed, the distance, and the time. You will often find the speed is never same in the two scenarios. Either there are relation between the distances or there are relation between the timings. For example, the relation between the timing is that initially the time taken was, let's say, t minutes. Then now the time taken by that person will be t plus 30 minutes, right? Because at a reduced speed, 30 minutes extra is being taken. On the other hand, if you look at the distance, then the relationship between the distances, distance traveled in the first case is same as the distance traveled in the second case. So in time, speed, distance, the basic principle is we always have to connect the multiple scenario based on some variable. That variable is either distance or time. Our job is to think on what variable can we form the equation more comfortably. And here it's quite evident that the distance is constant. Now we understand that distance can be calculated by the speed multiplied by time, right? So here the speed in the first case we have assumed is s, and the time in the first case is t. In the second case, the speed reduces to 3/4 of s and the time taken becomes t plus 30. Now we just have to simplify this, and the moment you simplify you get t is equal to 90 minutes. T equal to 90 minutes means the man starts 90 minutes before 10 a.m. That's the usual time that he leaves, because t is the usual time. That is, he starts at 8:30 a.m. So this will be the answer of this question, right? To answer this question, we could also have used another principle. I am not much in favor of that, but you can see I just discussed one of the principles, and that was the ratio of speeds is always equal to the reciprocal of the ratio of timings if the distance is constant. If you remember in the previous video, I told you this. So here we could have used this, that in the first case the speed is s, in the second case the speed is 3/4 of s. In the second scenario, the time is t plus 30, whereas in the first scenario the time is t. If you simplify this, it leads you to the same answer, right? And there is also another third methodology, and just for sake of understanding, I am explaining this here. That is that distance is equal to speed into time. See, the speed has been multiplied by 3/4. So to avoid the effect of it, because the distance has been constant, with time we should have another factor like 4/3. Only then this 3/4 will be cancelled out, this 4/3. So time, while initially it was taken t, now it is being taken 4/3 of t. That means the extra time is 1/3 of t, which is 30 minutes. So t equal to 90 minutes. That's the third method. It's completely your choice which method you want to pursue. I believe that the first method is fair enough, and then we should understand the concept exactly like this. So, having discussed this question, now I think I wish to take you to another question and finally sum it up. But this video has already been long enough for this question, so I'll just break it down here and we'll discuss the next concept of relative speed in the next video, and then we'll clarify all possibilities around the relative speed in that video. Thank you so much for watching my video.